I am Silvie Gibet from IRISA in France. I will present the paper entitled Signing Avatars, Multimodal Challenges for Text-to-Sign Generation. Sign languages are fully fledged languages, initially intended as a means of communication between the deaf. They belong to the family of visual and gestural languages, that is to say, they use the sensory motor system to produce the gestures and the visual receptors to encode and recognize the features. Like any gestural language, sign languages reveal an economy of linguistic representation, which is characterized by three main grammatical mechanisms. First, we can identify minimum units called phonological components that are structured to form the signs. Second, these units are organized spatially. Third, the signs and utterances formed by assembling these components follow a strong dynamics of iconicity, and this at all levels, from phonological, lexical, to syntactic and semantic levels. Phonological components are structured and expressed simultaneously on multiple channels, including manual and non-manual components. Manual components are executed by left and right hands. They contain placement of the hand, hand configuration, and hand movement. Non-manual components include facial expression and gaze direction. These components may convey different meanings. They depend on how they are combined with the other components and also on the context of the sentence. In sign languages, signs and sentences are organized in space. In the top right figure, we can see the signer's space, which can be divided into discrete areas along the three-dimension axis: height, distance, and radial. But the signing space goes beyond the physical or geometrical signer's space. It is an abstract, delimited space which allows a spatial thinking. In this signing space, thanks to the spatialization of signs, the references can be created and organized. The location, called locus, becomes the referent location of the entity. In pointing gestures, the pointed entity constitutes the meaningful information. It indicates the subject or object of an action. Thus, pointing with index designates entities previously defined. The pointed entity may represent an object or a pronoun like I, you, he or she. Indicating verbs correspond to signs that are inflected according to the agent-recipient relationship. The trajectory of the hand thus changes according to the agent and the recipient of the action. For example, the verb give can be inflected so that the starting and ending points change. In the example below, we have I give you a drink, where the gestures goes forward from the chest, or you give me a drink, where the trajectory is reversed. Iconicity is at the heart of sign languages. At the lexical level, the signs can be represented by concrete objects, symbols, or metaphorical concepts. Flexion mechanisms are a way to modify a sign by changing one specific component in this sign. For example, we see in the upper right figure that the sign bowl can become a big bowl if the shape and size of the hand trajectory is modified. Moreover, these entities can be placed relatively to each other with simplified and meaningful hand shapes called proforms. For example, in the lower figure, the index raised represents a pedestrian waiting for a car to pass, the car being represented by the flat hand with a forward movement. At the syntactic level, iconicity can be represented by relative placement of objects, also called, as for example, the ball is under the table, by verbs described by directions, also called indicating verbs. The beneficiary of the verb, also called the direct object, is represented by hand shapes. Different flexion mechanisms can be used. For example, we see in the upper right figure that in the two sentences, I give you a glass or I give you a coin, the glass or the coin are represented by different hand shapes. In the figure below, the two phrases use different hand shapes and movement directions. You give me a cup is represented by a line from a point in front of the signer to a point on his chest, with a closed C hand shape which is used. I give him a book, the line goes from the chest to the right side of the signer with the open C hand shape. Some gaits can also be represented by dynamic proforms. This is the case, for example, when we want to describe the gait of an animal, a cat, chicken, a lion, or a cow, for example. The shape of the hand is modified to represent the shape of the animal's leg. It is also possible to indicate by the movement of the hands the quality of the movement. A gait can be more or less heavy, smooth, with different styles. Facial expressions are of primary importance in sign language. They provide objective information that contributes to the semantics of the sentence. These facial expressions may represent adjective or adverbs, as for example, inflated cheeks make an object large or cumbersome. They also represent affect or clausal aspects, including negation, interrogation, condition. Different methods have been used to animate an avatar from mocap data, as can be seen in the right video for the affect anger. When animating hands for sign language, there are several errors that can be summarized by reconstruction errors that prevent from recognizing gestures, 3D modeling errors that are responsible for artifacts due to the approximation of the rigging, retargeting errors due to mesh specific to the recorded movement. One solution to the hand animation is to adopt an optimization approach by minimizing the local deformations of the mesh. Constraints can be added to the solution by incorporating an internal representation of the skeleton into the volumetric mesh. The construction of new sentences in sign language requires the combination of various components of the discourse, which implies mastering synthesis on each channel separately, multi-channel coordination, and the identification of temporal synchronization rules. And this while preserving the semantic coherence of sign language. In the example, we change the initial sentence, I like fruit juice, by the sentence, I don't like orange juice. The torso, lower body and left arm are unchanged, whereas the head is modified, as well the right hand shape and the right movement, which is reversed. This figure illustrates the two main blocks required to animate a signing avatar. First, the text to pivot SL generation block involves the translation of the written text in a natural language, possibly generated from audio signal, into the computational linguistic representation of sign language that is a written transcription of the signed utterances. This translation stage supposes that we are able to formalize linguistically sign language, taking into account the spatial and iconic representations, as well as the grammatical inflection mechanisms. Then, the pivot SL to 3D motion block allows to translate a symbolic written sign language, thanks to the pivot language, into a continuous 3D motion stream. thanks to an animation engine based on a multi-channel specification. Since sequence-to-sequence approaches have been very successful in recent years for translating one written language into another, we could think that the same would be true for sign languages. However, there are remaining technological barriers for automatic machine translation applied to text-to-sign generation. Indeed, concerning data, mocap data available for training neural networks model is still limited. More video corpora are available. Nevertheless, these corpora are insufficient today to cover the large spatial variability due to the many grammatical inflections of sign language sentences. Most importantly, unlike oral languages, there is a lack of aligned resources between text and sign language required to provide parallel resources for training models. To overcome this lack of labeled motion data, the solution could be first to pass through an intermediate language that would guide the learning process by introducing linguistic knowledge. 2. To propose generation models from natural language processing to written sign language, which, from typical examples, generate much more unlabeled data. And associate deep learning models that are free of annotation. Thank you very much for your attention. I will be pleased to answer your questions if you have any.